Okay, YouTube, in this video we're going to focus on sequences of transformation. So up until now we've discussed vertical shifts and horizontal shifts, as well as reflections over our X and Y axes, and also vertical stretching or shrinking, as well as horizontal stretching or shrinking. And these can basically be summarized with this table here. Essentially, without having to recap everything, I can tell you that you could pause your video and reflect upon these transformations here. What I want to do, though, is I want to be able to perform a sequence of transformations if at all possible. And so what we're going to do on this checkpoint 8 here is use this graph of f of x that we see on the left that is not actually defined by a rule. It is just this function that you see here with these 5 key points that have been listed. And what we're going to do is we're going to perform a sequence of transformations on this function f of x, given that we do them in a specific order. So we say a function involving more than one transformation can be graphed by performing transformations in the following order, starting with always the horizontal shift of our function. Now, recalling that horizontal shift happens when we take our original function and we add on or subtract off some constant to the x values inside this set of parentheses. Also, we know that this is an opposite shift that's occurring here, opposite. So if we're adding on a positive number here, it actually shifts to the left, c units, and if we're adding on or subtracting off a positive number, pardon me, it's going to shift to the right, c units. So knowing that we start with horizontal shift, we'll start with that always, and then we say stretching or shrinking would occur next. That would be if we were to multiply the y values here by a constant, or to multiply the x values here by a constant. We would get vertical and horizontal stretch or shrink respectively. And then last but not least, we have reflections and vertical shifting. So reflections, recall, occur when we either make our y values negative, which reflects it across the x-axis, or when we make our x values negative here, which will reflect it across the y-axis. And then the very, very last one we usually do is vertical shifting, which is always just this loose constant term on the outside here. So vertical shifting happens when we take our original parent function, and instead of adding on or subtracting off a positive number to the x values, we do it to the y values. So let's look at this example that I have here, this figure 2.49. We say that this is the graph of some f of x. You can see that that's listed here. It says, well, use the graph of f of x to go sketch this transformation here. And then maybe we can verbalize it. So the first thing I want to look at is this order that we do this in, and I said that we'll do our horizontal shifting first. So knowing that horizontal shifting occurs when we add or subtract some number to the x values, we could recognize that our horizontal shift is going to occur here with this positive 1. Now that positive 1, what that indicates is that actually all of these key points we see on our graph are going to shift left 1 from where they currently are. So instead of being at negative 2, 0, what we are going to have now is something that's at negative 3, 0, and would have shifted left 1 from there. So we'll shift left 1. We'll shift left 1 from 0, 3, which will put us at negative 1, 3. We'll shift left 1 from 2, 0, which puts us at 1, 0. Left 1 from 4, negative 3, which puts us at 3, negative 3. And then we would say left 1 from 6, 0 would be at 5, 0. So 1, 2, 3, 4, 5. And it'll now be located here. So we could say that just with our horizontal shift, this is our function that has been translated 1 unit to the left of what you currently see over here. So now our next step here would be to do this, would be to apply stretching or shrinking. So stretching or shrinking only occurs when we multiply the y values by a constant or the x values by a constant. And I notice that in here with the x, I haven't multiplied that x by any values, but we did multiply out front here this f value by negative 1/3. So that negative 1/3, as a matter of fact, is going to cause two things to happen. Because we multiplied the y values by a negative, we're going to have a reflection over the x-axis, and we're also going to have vertical shrinking since we multiplied the y values by a number that was between 0 and 1, or that is between 0 and 1, which is our 1/3. So what we'll do is first we'll shrink this graph by a factor of a third. So knowing that this is the point now negative 3, 0, and we have this here would be negative 1, 3. Here we have 1, 0. Here we have 3, negative 3. And then here we have 5, 0. What's going to happen is all of our y values on this function, that's our f values here, are going to shrink by a factor of a third. So that is to say I would take 0 times a third, and what I would learn is I would still be at a height of a third here. But when I say that this is 3 units off the ground, take 3 times a third, now it's now at a third of that original height. This is at a height of 0, so a third times our y value there is going to be 0 still. We say that this is at a height of -3, so taking that times a third actually makes it a third of its height off the ground, shrinks it back down vertically, and then a height of 0 times a third really doesn't move that at all. So we could see that this is our graph that's been moved left 1 but now been shrunken by a factor of a third. Okay, so what effect is this negative going to have on our graph? Well, we're aware that if we make the y values their opposites, take y values times a negative, what's really going to occur is that we're going to get a reflection over our x-axis. So again, making us reflect across our x-axis, really the y values become opposite of what they currently are. So I'm going to say that if it's already at a height of 0, reflection over the x-axis is not going to affect it. But if we flip this over the x-axis, now it's going to be located at a height of -1. This will be at a height of 0. This will flip above the x-axis, and then this will be right there. So now we have this graph, and I would say like a purpley color here, that has been shifted left 1 from the original, shrunken by a factor of a third, also reflected over the x-axis. The only thing we have left to do is to apply our vertical shift, and recall that our vertical shift shifts c units either up or down. In this case, because it's -2, will actually shift down too. So I would like to put my final graph over here on this unpolluted sketch here, but we'd say this was at a height of 0, really. It's at -3, 0. We'll be now at -3, -2. And if I shift this point down twice, it's -1, -1. Now it'll be -1, -1 down 2 more. And so this right here is at 1, 0. Now it'll be at 1, -2, since it's shifted down twice. This was at 3, 1. So we'll be at 3, -1 now. And then we can observe that this is 5, 0. So now it'll be at 5, -2. And so this would be the transformed function of the original. Cheers.